lessons today, and be sure to include today's date. Okay? Please copy all of this down, solving linear inequalities, lesson 6.1 and 6.2, and be sure to include today's date. Now, understand there are some similarities and differences between linear equations and linear inequalities. Okay? Here is one of the similarities. Please listen carefully. You use the exact same steps for solving linear inequalities that you used for solving linear equations, with only one difference, and we'll get to that difference a little later. Okay? Here's one of the differences. When you solve a linear equation, usually, not always, but usually, you have one answer for your equation. For example, if I had 2x plus 3 equals 7, brought the 3 over and made it negative divided by 2, I get out a number. Okay, one answer. 2. When you solve a linear inequality, you will usually get out a set of numbers for your answer. Not just one number, but a group of numbers. Alright, that's a difference. Now, since the steps for linear equations are just about the same as the steps for linear inequalities, let's start off by listing out those steps that we used back in chapter 3. Okay? I do want you to write these in your notes, so please copy them down. I'm going to move on like I always do, so pause the video, copy these down, and then move on. Simplify both sides as far as possible. Eliminate fractions. Move the variable terms to one side, the constant terms to the other side. Simplify both sides as far as possible. Isolate the variable. And that's it. Okay? Let's work on some problems. Are you ready? We're going to use these 5 steps. Okay? So here we go. Alright, I want us to start off with some easy inequalities. I want to show you what they look like, and then we'll get into this, okay? Here's a really easy, simple inequality, and we're going to solve this. Please copy this down. X plus 5 is greater than or equal to 3. Now, if that was an equation, it would look like this. You would have an equal sign right here. Okay? Thus, we call this an equation. However, we have an inequality here, so we call this an inequality. Okay? Alright, here we go. Let's solve this. Step 1, simplify both sides as far as possible. You cannot simplify this side, you cannot simplify this side. Step 2, eliminate fractions. No fractions you can eliminate. Step 3, constant terms on one side, variable terms on the other side. Bring your 5 over, make it a negative 5, and you're left with a negative 2. Next step, simplify both sides. That's already done. Last step, isolate the variable. That's already done. We're finished. Now you're probably saying, Mr. Earhart, you told us there was one difference. What's that one difference? Well, I will get to that later, okay, but not yet. So there's your answer. So your answer is every number that is greater than or equal to negative 2. Now let's say I asked you to graph this. I want you to graph it on a number line. Here's 0. Here's negative 1. Here's negative 2. Okay? You put a point there. Now, if it's equal to, then you close the point. Okay? If it's not equal to, if this had not been here, if you just had greater than, then you leave the point open. You do not shade it in. Okay? So understand that. Alright? So we have equal to. X is greater than negative 2, so we go this way, and then this way, and that's your answer. So do you see how we don't just have one number for an answer, we have a set of numbers for our answers. Every number over here, on and on forever, is part of the solution set. Any number over here, going on and on forever, is not part of the solution. Okay? And so, there we go. That's how you would solve that inequality. This is the answer. And the graph would look like this. There's the graph. Now, some students don't like to put the line going up like this. They like to graph it like this. They put a little squiggly marker, put an arrow. That's fine also. I don't care. It's up up to you. Okay? Alright, let's try another one. Copy this in your notes if you would, please. Let's try this problem here. We have negative 2 is greater than n minus 4. Okay, let's pretend that I asked you to solve this and to graph your answer, okay? Here we go. Step 1, simplify both sides. Already done. Step 2, eliminate fractions. Already done. Step 3, constant terms on one side, variable terms on the other. Bring your negative 4 over. Make it a positive 4. And you're left with 2. There we go. Okay. Next step, simplify both sides. Already done. Last step, isolate the variable. It's already done. So we're finished. Now a lot of students would read this like this. 2 is greater than n. 2 is greater than n. Okay? Do not read your answer like that. Okay? Do not. Always read your answer starting with the variable. So you start here and you say n is, it's less than. Notice how the little arrows facing the n. N is less than 2. That's how you would say that, okay? N is less than 2. That's your answer. Now how would you graph that? Well guys, you tell me. We have n is less than 2, so we go to 2 on the number line. Put a point there. Now, would I color it in? No, I would not, because there's no equal sign here. So you leave it open. It's called an open point. This is called a closed point. Okay? N is less than 2. So we start here and we go less than. You can do it like this. I have no problem with that. Or you can just go like this. Draw an arrow. Okay? So the answer to this inequality right here, the answer is every number that is less than 2. Now 2 is not part of your solution because there's no equal sign. If there had been an equal sign and we closed it in, then 2 would be part of your solution. But 2 is not part of your solution. It's every number to the left of 2, not including 2. Does that make sense? I hope that it does. Again, you would not read this 2 is greater than n. You would say n is less than 2. Alright, let's try another one. Excuse me. Alright, here we go. A over 3 is less than or equal to 12. Are you ready? Step 1, simplify both sides. It's already done. Step 2, eliminate fractions. Okay? We have a fraction. It has a 3 in the denominator. So we're going to multiply the entire inequality by 3. 3 over 1 times a over 3 leaves me with a. 3 over 1 times 12 is 36. Step 3, constant terms one side, variable terms on the other side. It's already done. Simplify both sides, already done. Isolate the variables, already done. We're finished. So you would read this answer. You would say A is less than or equal to, because of this line right here, A is less than or equal to 36. Now if I asked you to graph that, please do not feel like you have to put 36 tick marks like this. 1, 2, 3, 4, 5. It takes too long, okay? Just put something like, you can put a 10, a 20, 30, 40, and put a point about right here, and just put a 36 right there, and then put your point. That's good enough. Now, it's closed because that equal sign right there. And it says A is less than 36, so you can draw your graph like this. That's good enough. or if you want to, you can put that little squiggly line and put an arrow like this. Either way is fine, okay? But you understand the answer to this inequality is every number that's smaller than 36, including 36. Okay? Alright, now, you probably say, Mr. Arrow, you told us there are some differences between the steps that we use for solving linear equations and the steps we use for solving linear inequalities, and you're right, there are. There's a difference, and I will get to that in just a couple minutes, okay? Alright, moving on. Let's try another one. Please copy this down. You can work ahead or you can watch me. It's up to you, okay? 2y negative 5 is less than 7. Alright, step 1, simplify both sides. It's already done. Step 2, eliminate fractions. Already done. Step 3, move your constant terms to one side, your variable terms to the other side. Bring your 5 over, make it positive. 2y is less than 12. Next step, simplify both sides. It's already done. Next step, eliminate the coefficient, or isolate the coefficient, or excuse me, isolate the variable. Divide by 2. Y is less than 6. There's your answer. Finished. Now if I ask you to graph it, then you put a 0 here. Go over 6 marks. Put a 6. Put your point. Would it be open or closed? Well, there's no equal sign here, so it'd be open. Y is less than 6. So you can go like this if you want to, or you can go like this. Okay, either way's fine, but that would be your answer. Alright, let's try another one. Alright, here we go. 5 minus x is greater than 4. Alright, here we go. Now this problem here, I want your full attention on this problem because don't work ahead. This is the problem here where you're going to learn the one difference between using the steps for linear equations and how to solve linear inequalities, okay? So please pay attention. Okay, step 1, simplify both sides. It's already done. Step 2, eliminate fractions. Already done. Step 3, constant terms on one side, variable terms on the other side. Bring your 5 over, make it a negative 5. And you're left with negative x is greater than negative 1. Step 2, simplify both sides. Already done. Step 3, isolate the variable. Now remember there's a negative 1 here. So we're going to divide both sides by a negative 1. Now here's the new step, or the one thing that we don't do when solving linear equations that we have to do when we're solving linear inequalities. So I hope you will pay super, super close attention. Here, your 1's cancel, leaving you with x. Got it? Here we have a positive 1 because a negative divided by a negative is a positive. See this arrow? You turn the arrow. Now, look at the last problem. We divided by 2. Do you see that? It was a positive 2. So when you divide by a positive number at the end of the problem like this, excuse me, notice you do not turn the arrow, okay? You only turn the arrow when you divide at the very end by a negative number. Now that's the exception, and that's the one you need to know, okay? When you divide an entire inequality by a negative number, you must turn the arrow. So there's your answer. And now let's graph it. Here's 0. Here's 1. Your point will be open. X is less than 1. So we go this direction here. Or like this. Okay, guys? Alright, let's try another one. This will be another one where you have to turn the arrow, so pay attention. And by the way, this is the main thing that most students forget to do, is to turn the arrow. Okay, there we go. Step 1, simplify both sides. Already done. Step 2, eliminate fractions. Already done. Step 3, move your constant terms to one side and your variable terms to the other side. So guys, let's bring the 4x over and make it a negative 4x. Let's bring the negative 4 over and make it a positive 4, okay? Positive 2 2, negative 4, that's a negative 2x. Negative 1, positive 4, that's a positive 3. Bring the arrow, bring the inequality down. Now, step 4, simplify both sides, already done. Step 5, isolate the variable. So we're going to divide both sides by a negative 2. Now listen to me. If we were dividing both sides by a positive number, we would not turn the arrow. Okay, you would just write x is greater than or equal to 1.5, because 3 divided by 2 is 1.5. Okay, but we are dividing by a negative number, so when you divide by a negative number, you take your arrow and you turn it. These cancel, leaves you with x. A positive divided by a negative is negative. 3 divided by 2 is 1.5. Or 1 and 1/2 if you want. Okay? So there's your answer if we graph it. Here's 0. Here's negative 1. Here's negative 2. Negative 1.5 is right here. Put a point there. We do close it because of the equal sign. And its x is less than negative 1.5, so we draw it like this. Is fine. Or we can just go like this, which is fine also. So every number less than negative 1.5, including negative 1.5, is an answer to this inequality up here. And students, that's all there is to solving linear inequalities. They are very, very simple as long as you remember that when you divide by a what type of number? Negative number, you must turn the inequality arrow. Alright, I hope this video has been a help. If you have any questions, don't hesitate